So here we're looking at graphs of quadratic functions, which we call parabolas. They'll have certain things in common. And when we use quadratics to describe real-world phenomena, when we do some modeling here or some word problems, understanding how this graph works is going to help us understand the thing that we're looking at. So we need to have a little bit of vocabulary and understand what's going on with this shape. Now, obviously, as we go from left to right, this graph is coming down from infinity, turning around and going back up. It happens to be symmetric, right? Both sides the same shape. And it has a point right here that is its lowest point that it gets to. Now, what we call this, where it turns around from decreasing to increasing, which also happens to be the lowest point, we call this the vertex. Okay? And if you've got a graph, it's really easy to find. We'll talk about how to find it from a formula next. But this point here is obviously from the origin over 1 up 2, so that's -1, comma 2. There's your vertex. Done. Now, I said it was symmetric, and the line that it's symmetric about, meaning the line that divides it exactly in half, so if we were to fold it on that line, both sides would match up. That's called the axis of symmetry. And it's a vertical line, so its equation is just x equals whatever the x coordinate of all of those points are, and that's real easy. That's x equals -1. I know people don't like it when I call things easy, but remember my definition. It doesn't take much work if you know what you're doing, and that was not much work. Is that point a maximum or a minimum? Is that the highest point on the graph or the lowest point on the graph? I can't believe I just asked that in a college level class. Obviously, that's the lowest point, so it is a minimum. Now, these next parts are kind of irritating. They involve interval notation, and I think they're unnecessary, but in my math lab, they're going to ask you for these, so you don't want to have those little red check marks, those little red X's in your my math lab assignment. So what is the interval on which this graph is increasing? Well, it's going up on this side. Remember, we talk about increasing or decreasing. It's always as we go from left to right. So this graph is decreasing over here and then increasing over there. And the interval it's increasing on, think about the x-axis, right? This is where it stops at -1. And then on that side, it's increasing. So from -1 to infinity, this thing is increasing. Parenthesis, because it's not fair to say it's increasing at -1. It's only increasing after -1. And it's decreasing from -infinity, from this end of the number line, up to -1. So -infinity to -1. All right, these are both x-axis answers. The interval on which something is increasing or decreasing is basically asking, as you move along the x-axis from left to right, is the graph going uphill or downhill? The range asks about y values. Okay, we want the range of this function. We're going from -infinity here, no graph, no graph, no graph. We start getting graph when we get up to 2 on the y-axis, and then all the way up to infinity. So that's our range, 2 to infinity. And do we have a point at 2? Yes, we do. That's the vertex, so bracket to show that. Now, when I say this is easy, it's not much work. In fact, there's only 2 numbers really involved here. There's the x and y coordinate of the vertex. That gives us the axis of symmetry. It gives us the range. As long as we understand whether this thing is right side up or upside down, has a high point or a low point, we know how to write our intervals for increasing and decreasing. A similar one here, except it's upside down. So for this particular one, the vertex is the point where it turns around, which is 2 comma, 1, 2, 3, 4, 5. So 2 comma 5 for the vertex. The axis of symmetry is always a vertical line. When we're talking about quadratic functions, it's always a vertical line through the vertex. So x equals whatever the x coordinate of the vertex is. Is this a maximum point or a minimum point? Well, it's a highest point. That's a maximum. The interval for increase, this time it's increasing on the left side and decreasing on the right. So it's increasing from -infinity up to 2. So -infinity to 2, that's a parenthesis, not a bracket. And then from 2 to infinity, it's decreasing. And then our range, this time our graph goes all the way down to negative infinity and all the way up to, on the y-axis, 5. So from negative infinity up to 5, and there is a point at 5. Okay, so not a lot of work here, just for half of it, remembering how to write the answers out, where to put the intervals and all that fun stuff.